Before we work out how to find the number of valence electrons in an atom, it's worth quickly highlighting what valence electrons actually are. And they are simply the electrons found in the outer shell or energy level in an atom. So how do we find out the number of valence electrons if we're given a particular atom? In order to do this, let's take an example, perhaps a nitrogen atom. And there are going to be three possible options depending on the information we're given about that atom. Option A might be using the electron arrangement which we obtain from a Bohr model of that atom. And as a quick reminder of what the Bohr model looks like for nitrogen, it would be something like this. And you can see I've drawn the electrons in the energy levels. The first energy level can contain the maximum of 2 electrons and the second energy level maximum of 8 electrons. So in the case of nitrogen, which has 7 electrons, I put 2 in the first energy level or shell and then the remaining 5 in the second energy level. Once I'm able to draw that Bohr model, the electron arrangement simply looks like this. 2 describes the number of electrons in the first shell and 5 describes the number of electrons in the second shell. So because with valence electrons we're only interested in the electrons in the outer shell, the interesting number for us here is the 5, which is referring to the 5 electrons found in that outer shell. Option B is using the electron configuration of my nitrogen atom, which is obtained using the atomic orbital model of the atom. As a quick reminder, if you can't remember what that is, it's a model of the atom that takes into account that each energy level is actually broken into sub-levels. And we can use that to draw an orbital box diagram that looks something like this. Of course, because it's a nitrogen atom, it's still got 7 electrons, but this time we've placed them in these sub-levels from 1s, then the 2s, and then the 2p sub-levels. If we understand that process correctly, we can then write an electron configuration for a nitrogen atom that looks something like this. And in my electron configuration, I'm simply describing how many electrons are in each sublevel, starting from the lowest energy 1s sublevel and building my way up until I've used all my electrons. Once I have my electron configuration, I want to identify the highest big number, which is referring to the energy level, and in this case the highest big number I can see there is 2. So both of those sublevels, the S and P, are belonging to the second energy level, which is my outer energy level in this case. So in order to work out the number of valence electrons in that outer energy level, I need to look at the small superscript numbers up here, the 2 and the 3, add those together. Again, that is 5. So for both option A and option B, we need a little bit of understanding of the respective atomic models. However, there is a much quicker and easier way to find the number of valence electrons, and that's using the periodic table. So here is the IB chemistry periodic table. All rights belong to them, just in case I get sued. And the group numbers are found along the top of the periodic table. In the periodic table, one of the many clever ways that the elements are arranged is that the group number can actually be used to identify the number of valence electrons. So for example, in group 1, those elements will have 1 valence electron. In group 2, they will have 2 valence electrons. And then we're actually going to just skip the middle section, or the D block, because this process doesn't work with them. So ignoring groups 3 to 12, when I get to group 13, each of those elements will have 3 valence electrons. Group 14 will have 4 valence electrons, 15, 5 valence electrons, 16, 6, 17, 7, and 18, 8. So referring back to our original example of a nitrogen atom, well, if I can identify nitrogen in the periodic table and see that it is in group 15, then we know it will have 5 valence electrons. So let's have a quick look at the key points from this video. First of all, valence electrons are the electrons found in the outer shell or outer energy level in an atom. And there are 3 ways we might identify the number of valence electrons. The first of which is the electron arrangement, and this uses a Bohr model to state how many electrons are in each shell or energy level. We're interested in the last number. Secondly, we could use the electron configuration, which comes from the atomic orbital model of the atom. And in this case, we're looking for the outer energy level, which would be the second one. And I'm counting the number of electrons in total in the sublevels of that second main energy level. Thirdly, and most simply, we can look at the group number in the periodic table. Remember that for elements in groups from 13 to 18, we can effectively take away the 1. So 13 has 3 valence electrons, 14 has 4 valence electrons, and so on. And that's pretty much it. Hopefully this was of some help.